Okay, we left off right here, finding the rectangular coordinates of these polar coordinates, with r being 6 and theta being 2 pi over 3. We know that x is r cosine theta, so we're taking 6 times the cosine of 2 pi over 3. You either do that on your calculator, or you remember that the cosine of pi over 3 is a half. So 2 pi over 3, since we're over here in the second quadrant, would be negative a half. So, what am I doing? That's not 6. So x is 6. X is 6 times cosine of 2 pi over 3. 6 times negative a half, comma. Y is 6 times the sine of 2 pi over 3. Well, the sine is positive, what, square root of 3 over 2? So it looks like our rectangular coordinates are negative 3 root 3. And 3 root 3, if you do that on your calculator, is about 5.2. If I do 3 root 3, let me think. 3 times square root of 3, 5.196, yeah, 5.2, we'll say, okay? So, negative 3, 5.2. That's where I think has a radius of 6, and this angle would be 2 pi over 3. That's what we're saying. If I either plot the point negative 3, 5.2, that's the rectangular point, or I go an angle of 2 pi over 3 and draw a line that's 6 from the origin and put a dot there. Either way, the same. Okay, there's only one rectangular coordinates that go with this. Okay, we're done. Negative 3, 3 root 3. Graphing that on here, what was it? 6, 2 pi over 3. Okay, again, I'm going to let each circle represent 2. 2, 4, 6, 8, 10. Okay, so I'm going to go 2 pi over 3. So this is 90, or pi over 2. Okay, and so this would be 2 pi over 3, right? Or 120 degrees, right? 90, I'm going by 15. So I'm going to go right on that, right on this line, 2, 4, 6. Okay? Well, if this is negative 2, negative 4, negative 6, 2, 4. If I think of it rectangularly, we said that this is the same as negative 3 and about 5.2. So if I would plot the point negative 3, let's see, I'm going to go up 5.2. Here's 5, so a little bit more. Yeah, that's the point, negative 3, 5.2, or it's something that has a radius of 6, 2, 4, 6, and is at the angle 2 pi over 3. Do you understand? Same point, same point described in polar coordinates or described in rectangular coordinates. Okay, let's try and find the polar coordinates of this. I have x is negative 2 and y is negative 2 root 3, which is about 3.5. 3.46, let's say 3.5. So I'm at negative 2. I always like to see what quadrant I'm in. Negative 2, negative 3.5. Jeez, sorry. Negative 2, negative 3.5. About here is where I am in the third quadrant. Okay, polar coordinates. Well, let's find r first. I know that r is the square root of x squared plus y squared. So that'd be 4 times 3. Oh, this is convenient. R equals square root of 16, which is 4. Okay, fantastic. I also know I have to find theta, and I know that the tangent of theta is y over x. So that's going to be negative 2 root 3 over negative 2, which is square root of 3. So it looks like theta, okay, tangent of theta is square root of 3. If I do inverse tan of the square root of 3, I get pi over 3, or 60 degrees, depending if I want this in radian or degrees. Does that make sense? Does this look like, is that 60 degrees? You have to be careful. Don't just blindly put that. I got 60 degrees. Okay, that's great, and that'll help me find, but I realize that I'm in the third quadrant. There's another place where the tangent of theta is square root of 3, right? At 4 pi over 3, or 240 degrees. Okay? Is that all right? Okay. So I just have to be careful. My polar coordinates then are, what did I say? 4. 4, comma, 4 pi over 3. Or if you're going to do degrees, 4, comma, 4 pi over 3 times 180 over pi. If I want to change it to degrees, if I'm not sure, 240. Okay, if you don't have the unit circle quite memorized. There's other ways. I can add 360, etc. I could think of the negative angle here. Okay, would that be negative 210? Okay, so I can say 4 negative 210 degrees. Oh, not 210. Good gracious. Sorry. I'm dyslexic today. I was put my 1 and 2 in the opposite direction. Negative 4 negative 120 degrees. And that'll get me there too. And then I'll go 4. If I don't have the polar. I think I gave you the polar to do it. You can graph that on the polar coordinate system. Another way, guys, if I wanted to use, since I went this way, if I want to use 60 degrees, I can say negative 4 pi over 3 or negative 4 60 degrees. That means go 60 degrees, and instead of going 4 in this direction, go 4 in the opposite direction. Okay? I could call it that. Remember, there's not a unique ordered polar coordinates like there's a unique ordered rectangular coordinates. Okay, now we're going to look at some equations. Y equals x minus 2. I know what that is. It's a line. Slope of 1. Oh, geez. Slope of 1. And it goes negative 2 is the y-intercept. Okay, writing that in polar form. Since I know that y is r sine theta, I know that x is r cosine theta. Okay, we usually would, I'm going to add 2 over here and subtract this r sine theta here just because I prefer to have a positive 2. I'm going to factor my r out. When we have a graph in polar coordinates, in polar form, we want r equals instead of y equals. So I have r equals 2 over cosine theta minus sine theta. Okay, that's the way to write this line in polar form. If I wanted to graph it, I would go boom, y equals, oh, I'm not going to do y equals. I forgot to go change my mode. Mode, watch this. I'm going to change, I'm just going to put radians. It doesn't really matter, but I'm going to go to polar coordinates. Okay? I want polar. So now watch what happens, guys, when I hit y equals. Oh, it switched to r equals 2 divided by parenthesis cosine. Now watch what happens when I hit x. It automatically goes to a theta. See how this says xt theta like that? Those were all in case I'm in a different form. Cosine theta minus sine theta. Graph it. Well, what do you know? Does that look like y equals x minus 2 to you? It looks like y equals x minus 2 to me. I don't think it matters if we write it. I'm not going to do that. Okay. Alrighty. So, it's that cool? Let's try this one. X squared plus y squared equals 9. This is my favorite. Remember what this is? We did it in college algebra. This is a circle with the center at 0, 0 and a radius of 3, right? Well, x squared plus y squared. Doesn't that equal r squared? Isn't that what we learned way back here? Gracious sakes. Somewhere here. Yeah. R squared equals x squared plus y squared. Right? Okay, we've been using that. Well, don't forget, we use it here too. It's not just true sometimes, it's true all the time. R squared equals 9. So that means r equals 3. I want a circle. Well, all this means is, hey, the radius is going to be 3. Theta can be anything. Okay, but the radius is 3. Maybe theta is 90 degrees. Maybe theta is 180 degrees. Maybe theta is 270 degrees. Whatever theta is, my r, my distance from the center is 3. I get this circle. Isn't that a great way just to say r is 3 instead of x squared plus y squared equals 9, even though that gives me the circle too? Kind of cool. Watch. Y equals, let's clear this off. I'm just going to say 3. I've changed to polar form. I'm saying that r equals 3. Let's graph it. Oh, it's a circle with a radius of 3. Is that neat? If I change back, let's change my mode. Now I can't actually do, I can only do functions on this calculator. And a circle is not a function, right? So I have to do 2. I have to do the top half of the circle. Y equals the square root of 9 minus x squared. Can you please? Okay, there. And y equals negative the square root. We do it in 2 pieces of 9 minus x squared. Right? Remember the semicircles, the 2 semicircles? In other words, I'm taking this and I'm subtracting x squared, and then I'm taking the square root. Okay, and so with a plus and minus, I'm not going to have a function, so my graphing calculator is limited to just graphing functions. So I'm going to graph both these. That's the same as just x squared plus y squared equals 9. And I graph it, and I get the same circle that I had in 2 pieces with just r equals 3, right? Same thing, whether I have, whichever way I have it. Okay, on the polar form, if I want to do r equals 3, I go, let's just let these be 3 now, okay? 1, 2, or let each one be 1. 1, 2, since I can. 1, 2, 3. Here's another place where the radius is 3. And these are nice on here. 1, 2, 3. I start seeing where I am. Graphing it on here. Oh, sorry, I'm not very good. That's r equals 3. Circle with radius 3. Alrighty. We're done, I think. Oh, okay. All right, guys. Oh, no, we're not doing that. Oh, yes, we are. R equals 2, because this is the other one that was, that I already showed you. Okay, so it's still the same graph. We go down to, and a slope of 1. Okay, not that you have to do that on the polar, but oh, and then this one, write an equation in polar form. Again, I would get this would be r sine theta equals negative r cosine theta plus 1. I would add that to the other side. Factor your r out. And divide. So you have 1 over cosine theta plus sine theta. This equation and this equation will give you the same thing. Again, you can test it graphically. Of course, we know what y equals negative x plus 1 looks like. Not really going to waste time with that.